All right, welcome everybody. Welcome to the Test Guild event for QuerySurge. So today, in my segment, I'm going to be talking about creating a project plan for a data warehouse project. A little bit about myself. My name is Chris Thompson. I'm a senior domain expert, data testing practice. I'm a military veteran. I spent 5 years in the United States military, flying inside these things called P-3 Orions, a sub-hunter. I have a bachelor's degree in computer science from the University of Delaware. So I've done successful implementations of QA projects in the data space for well over 15 years. I've been with RTTS for 21 years, and I started with RTTS as an entry-level test engineer coming directly out of college. I worked in numerous fields, including pharmaceutical, utilities, and retail. And that's me. And here we have Mike. Mike?
Yeah, thanks, Chris. So I joined RTTS as a test engineer back in 2009. So during that time, I've gained over a decade of experience in successfully implementing both automated testing solutions as well as data and ETL validating testing solutions. Technical expert on QuerySurge, our flagship data testing solution, and currently helping clients around the world with their QuerySurge implementations. I have a bachelor's in science from Hofstra University in computer engineering.
All right, thanks, Mike. All right, so I'm going to give a little bit of an introduction into ETL testing and specifically for creating a project plan around data warehouse testing. So data testing is an integral part of our development of any data project, including data warehouses, data migrations, and integration projects. Bad data from defects can cause companies to make decisions that could cost millions of dollars, or in health-related fields, could cost dearly for somebody their lives. One of my first clients was a big pharmaceutical company. I had no idea what data testing was. I was sent there as a functional automation engineer with some background in Rational Robot, for those that remember that tool, and also Mercury Windrunner. Well, they happen to have Mercury Windrunner, and I was trying to test a data warehouse with Mercury Windrunner, and it didn't go too well. I ended up having to use a lot of SQL, and I actually did use Windrunner to execute that SQL, bring back results into a very antiquated database called Microsoft Access, and that's where I would do the comparisons using minus queries, which we'll talk about here shortly. Minus queries, we started off with using Windrunner and using minus queries, and it was very inefficient, took a long time to execute, and could not complete our task doing it that way. So eventually we built a utility in VB, which eventually became QuerySurge, but we'll get into that a bit later. A little bit more about the reasons why we want to test data is Walmart handles more than 1 million customer transactions every hour. Data is imported into databases that contain greater than 2.5 petabytes of data, equivalent to 160 times the information contained in all the books in the U.S. Library of Congress. Additionally, we have Facebook, 40 million photos, Twitter with 85 million tweets per day, Google 1 terabyte per hour, and eBay 80 terabytes per day.
So there's a lot of data out there.
A hell of a lot. So what is a data source? A data source is a pool of data available for extraction. The concept of a data source is technologically neutral. It's not associated with any specific technology. The most common data sources are databases, files, and XML data documents, but it could be just about anything that we can get our hands on. In my example of the pharmaceutical company, we were doing adverse events, which is, say you took Tylenol, got a nosebleed or something, and you went to the doctor would enter that information into an adverse event system, which would be the source system that would eventually end up in the pharmaceuticals data warehouse. So all that data would be collected, and there could be many, many different systems from different states and different hospitals that would eventually need to get translated and loaded into a master data warehouse for that particular company. So what is a data warehouse? It's a collection of data or information intended to support business decision making. Data warehouses contain a wide variety of data that present a coherent picture of business conditions. Data warehouse is a huge repository of electronically organized data mainly meant for the purpose of reporting and analysis. Most data warehouses are sent data from multiple sources, such as my example came from a hospital, could come from a doctor affiliate somewhere. So many different places. It could be files, come in as files. It could come from an Oracle database source. It could come from proprietary software, all different types of sources. It's a place where historical data is stored for archival, analysis, and security purposes. All right, so what is ETL? And ETL is a term that describes extract, transform, and load. It refers to data handling process that involves extracting data from outside sources, transforming data to fit operational or reporting needs, and then load that data into an endpoint. Usually a database. In this case, for today's example, we'll be doing a data warehouse. So why ETL? Well, businesses need to load the data warehouse regularly, incrementally, daily, and weekly so they can serve its purpose of supporting business analysis. So basically, we take a whole bunch of sources from different places, we put it in the same type of format so that we can run reporting across all those sources. So it's transforming the data into one set standard. Here's an example of that. So on the left side, we have a whole bunch of source systems. They go through an ETL process and eventually get to a target data warehouse. And another example, we have multiple systems. They could be different. We have an inventory system, a customer service system, and an advertising system, all sort of asking different questions, right? The paint came off my widget for customer service. That would end up in a data warehouse, which then could end up in data marts and then be pulled out by BI tools to say, we have hundreds and hundreds of widgets where the paint is falling off. All right, so the concept of test points or ETL legs. An ETL leg refers to a single ETL process that moves, transforms data between two discrete points. So from source to target is a test point or a test leg. A full ETL process may have multiple legs. So in my previous slide, you saw that there's a data warehouse and a data mart. So each one of those is a separate leg, and we'll show that in the next slide. Test points are usually across single ETL legs. The verification is between the source and the target for that leg. And I'll talk about that in the next slide as well in more detail. An example is an operational source database. Source test point is extracted, transferred, and loaded into a data warehouse. Testing is conducted across this leg here. So here's an example of the different types of test points. So in the example above, it's a multi. So what we're going to do is we're going to say our data source over here, and then we're going to test all the way across to our data mart. So we're going to test all these transformations in one leg. And then on the bottom example, it's breaking it into its separate entities. And both have advantages and both have disadvantages. But the single approach has, in my opinion, more advantage. In a single leg, we have more tests that need to be created, right? Because there's more legs, so the same tables and the same data needs to be tested across each individual ETL leg. The tests are less complex because you could have transformations occurring across multiple legs, and if you were going to test the whole thing as a whole, you would be creating that transformation logic in your SQL to be able to test from source all the way to its final destination. Defects are easier to pinpoint. So you can imagine in the multi-leg approach, if there's 6 or 7 legs that occur and you're testing them all in one go, and you find a defect or an error or a bug, where in that 6 or 7 leg process did that defect occur? So it's more difficult. You have to dive a little more deeper into the data, and you may end up having to create tests for in the single leg approach anyway, just to find that defect. Additionally, for the single leg, execution time tends to be longer. So this is a little bit of a disadvantage, but it's not always the case. We have more tests to execute. Even though they're automated, they still take computational time and hardware to be able to execute those. And in the multi-leg, just quickly, there's less tests that need to be created, obviously. Tests are more complex, like I discussed. Defects are more difficult to pinpoint, like I discussed. And execution time tends to be shorter because there's less tests.
Is it usually, Chris, you would say one or the other, or could there be sort of a mixed approach here where you'll do both single and multi-leg tests?
You could definitely have a mixed approach.
Mm-hmm. That's what I usually find too in the projects that I work on.
Some of the direct mappings where a particular column doesn't have any transformations at all across all the legs to its final destination, it might be worthwhile just to create a test that just tests those one-to-one mappings across the entire thing, and that way you don't have to create those simple tests at each leg of the testing process.
Yeah.
All right, so now I'm going to talk about a data mapping document. A data mapping document is frequently called a source-to-target map and is generally created in a spreadsheet. This document acts as an essential part of the functional requirements. The following information is contained within the document. So normally a mapping document would contain your source database information, such as your source table, source column. Additionally, same thing with your target table, target column, any transformation logic, and any optional types of requirements.
Yeah, definitely one of the most important documents when you're doing a data testing project.
Yes, this is it. This is what you need to get to be able to really test an ETL process correctly. I've been on client sites where they don't even have a mapping document, and I have to reverse engineer what they've done to be able to determine what they actually did to come up with a mapping document on my own, then to get business approval that is the way it's supposed to be. Because the development team had done it through verbal techniques of creating what is supposed to happen. You seen that before, Mike?
I've definitely seen that, Chris.
Anyway, here's an example of a segment of a mapping document. We're going to get into this a little bit in more detail. Some of the transformation types that we see, and this is not all-inclusive, but direct maps, which are just one-to-one mappings, where the column and target, or the column from the source to the target goes through no transformation whatsoever. It's just a direct pull. Selective column and row type. This is where we might do some filtering to bring only specific columns or specific rows over into the target. Translation, this is where we translate one thing into another. So we could have, say, in the source side, we could have state names like New Jersey, New York, etc. And in the target, we have NJ and NY. So that would be a translation, translating the name into its abbreviation in this case. Lookups. Lookup is where we take a particular item. It's similar to translation, but we look it up in another table to figure out what the value should be. Transposing is where we take columns and turn them into rows, or rows into columns. We don't see it very often, but I have seen it in the past, so we put it on the list. Field splitting, an example of field splitting is in the source side, we have a full name column where Chris Thompson is in that field, and we're going to split that into two columns, one for first name and one for last name. So it would be first name Chris, last name Thompson, so one column into two. Field merging is exactly the opposite. Say in the source side we have Chris Thompson, but it's in two columns, one for field, one for last name, and we put them together in the target side. Calculated and derived fields. These could be very, very complex to relatively simple. Take, for example, a sales database, and I want to aggregate into the data warehouse particular values, say for the month of August, all the sales dollar amount for a particular month. We would calculate that and load that into the target, and that would have to be tested to make sure those calculations are correct.
Some of these seem more complex than others, and I have a feeling that's going to become important.
Absolutely. How did you guess, Mike? So some testing methods. So I'm not going to go into them all or in any detail, but there's the what we like to call stare and compare. So we run some SQL or we export stuff into Excel, and we look at it side by side and make sure the fields were migrated correctly. Obviously, this is very error prone to human error. Also, how much data can you really test doing it that way? The second method that I'll talk about is the minus queries. So this is where you take the source minus target and you end up with a result, and the result would be the difference between the two. However, if there are columns in the target and you do source minus target, you will not see those columns or rows. You would have to do it correctly, you got to do source minus target and then union target minus source to get the full difference. This is highly time-consuming and taxing on hardware.
Sounds like double the work.
It practically is double the work, Mike. So QuerySurge comes in to play here. Automation with QuerySurge. So this is bulk data verification. Testing sample sizes up to 100%. We have lots of clients that do that. We have management of our test assets within QuerySurge. It stores all your tests. Well, we call them query pairs, but QuerySurge stores them all, and you could also group them together into what we call test suites. Test scheduling, so say every day at midnight, an ETL batch job occurs and new data ends up in my data warehouse, and I just want to test that data, but I want to execute it when the ETL completed. Then I could schedule to say run QuerySurge at 3 o'clock in the morning and run this group of tests so that when I come in the morning at 7, I have instant results waiting for me. Persistent access to test data. QuerySurge stores in its own database all result sets, so you can go back in time to see what occurred on previous executions of your tests, and robust reporting to see how many tests passed, how many failed over time. An automated data testing approach with QuerySurge can significantly improve coverage, organization, and efficiency when compared to the previous mentioned manual testing techniques. All right, enough with QuerySurge. Let's move on to, all right, so what we came here to do is to show you a simple process for a simple project of creating a project plan. So some of the things that we're going to need is we're going to need to gather some project documents. So that mapping document, of course, the most important one, we're going to have to gather any other supporting requirement documents, data model documents. We're going to have to estimate the time it's going to take us to review all that documentation and determine the number of test engineer resources, determine the number of ETL or test legs, determine the number of cycles or releases. Additionally, which is probably the hardest part of this whole process, is determine the complexity of each mapping. So we have low complexity, which this is no standard, it's just what we think is the best approach. Is low complexity has no transformation logic. They're all one-to-one mappings, or have very minor transformation logic, including a change to data types from source to target, such as a varchar being converted to an integer, selective row filtering, and minor translations. We also have medium complexity, the transformation logic including translations, joins across tables, field splitting, and field merging. And then we have our high complexity transformation logic including major translations, multiple joins, calculated or aggregated fields, transposing, derived fields, and match and merge. We also need to know if QuerySurge is installed and configured for the project. And does the lead or test engineers require training? All right, so I'm going to now jump over to our mapping document for today, which comes from our QuerySurge tutorial. So this is available for anybody that downloads a QuerySurge trial. They will get the documentation for the tutorial as well as this mapping document. So there's a bit of a story of this tutorial sample companies coming over to a data warehouse. We have two companies, Z-City and XSmart, and that data is being ETL'd into a MySQL target data warehouse. For today, we're just going to do the project plan for this leg here, the Z-City part being ETL'd over into the target data warehouse. Here's the data model for Z-City. Very complex. What do you think, Mike? 3 whole tables.
I mean, it seems like a lot, but given the time frame we have, maybe it's all we can do right now.
I agree. So we have 3 tables: purchaser, sales, and sales item, and we have the MySQL data warehouse, which has DIMS.
Now we're talking.
Now we're talking, right? DIMS and facts, a little bit more advanced of a schema, and here is our lovely Z-City mappings for our data warehouse. So we have mappings, which is just a mapping number, a source table, the source column, the source type, transformation logic, the target table, target column, and target type. And we also have some comments if there's additional logic that needs to be applied, and an example of what the data looks like. So we're just going to go through each one of these and talk about the translation type that is occurring, as well as what we think are low complexity, medium complexity, and high complexity. So we'll look at the first one, Mike. We're looking at auto sequence with the target table, customer DIM. It's an ID, customer ID. It's also a primary key, Mike, and it's an integer. So what kind of translation type do we think that could be?
I'm kind of leaning towards low complexity here. We're just incrementing things here, right?
It's just an auto sequence, so we're just going up 1, 2, 3, 4, 5, 6, 7 on the target side.
I'm going to say between low and medium. I can't decide. I don't know.
All right, let's see what I guessed. Well, I said translation medium. Mike, what do you think?
You know what? Now I'm thinking about it, that kind of makes sense. We'll have to apply some tests to make sure that the auto sequence is being done properly. We're seeing this as a primary key too, right? So we're going to make sure there's no duplicates in our test. So we're going to have to get a little bit more complex than just a straight count and direct map. So I agree.
All right, good. Because I was going to override you anyway. All right, so now we got 101. This is a direct map, so this is pretty simple. It's a varchar to a varchar, and so Mike is.
I'm going to guess low. It's a direct map.
You sure it's not a high one?
No, it's definitely not high.
No, you're right. All right. It's a direct map. All right, so now we can go into something a little bit more interesting. So here we have the example that I've been talking about during the slide presentation is the full name field in the source column. In the target data warehouse, it's 2 columns, first and last. And so we extract the data, customer dim dot first from source purchaser dot full name by splitting full name by the space and taking the first substring. All right, what do you think, Mike?
Well, so we have a full name column. That means the whole name is on the source side, and then we're going to split out the first name here, huh? So we definitely have some transformation logic. I'm going to say that's a medium. I mean, there is some logic here, but maybe it's not that complex. Something that we can code around here.
And that's what I got, field splitting and medium. And similarly for the last name field, it's going to be the exact same thing, field splitting, medium. All right, so what about the purchaser date join field being a direct map? Except there is a join, Mike. There's a join on the customer dim table to the date dim table on the customer dim join date ID. Date dim ID and pull date dim ID.
Well, I mean, you say direct map, I almost think low complexity, but you're adding some complexity here with this join. So I'm going to categorize this. I'm going to guess medium here.
Yeah, we got a medium. All right, so additionally, I would continue on going through this process with Mike, and eventually we've come to an agreement on everything. For these next few, I will pull up something a little bit more complex, which is the one down here, actually, purchaser bill same. So on the source system, we have columns for both the billing address and right here. the shipping address and the billing address. However, you will notice in the data warehouse, we have a single table that contains all the addresses, and then on the customer DIM table, we have the shipping address ID and the billing address ID. So this has to be ETL'd over, and it's a little bit more complicated of a thing to do. So there's some logic here, and I won't read it. I don't want to bore anyone, but if anybody wants to read it, take a look at our tutorial data. But obviously this is a bit more complicated than your standard one, as we are doing one thing for one way, and if the bill and shipping address are the same, and something different if they're both different. So what do you think, Mike?
Well, since you haven't done it yet, I'm going to guess this is high complexity, but also because of the fact of this transformation logic that we see here. Looks quite complex. Developing a test around it, I think will be pretty involved. So I'm going to guess high here.
You put the answer.
Well, let's agree on it's a high then. I mean, if we were going through this
It's
document ourselves.
I was saving it for you.
Yeah.
Oh, no, it's still white. That's why. I didn't highlight the whole thing. That's okay. All right, it's high.
There you
There
go.
we go. All right. And additionally, to save some time, we've gone through this together, and we've come up with our results across the board for this entire table, as well as these other tables that I did not hide the thing for. So we have 3 tables from the source side coming over in the data warehouse, and we've figured out the complexity for each one. And now I can move on to the next part of the project plan creation. All right, so now back to the creation of the project plan. We now have some information on our complexity of our tests. I additionally pre-filled out some information as well. So we have I estimated 4 hours to review the documentation. What do you think, Mike? You think that's good?
Yeah, I think so.
I'm going to be the lead, and I have selected Mike to be the test engineer. So, all right, so now back to the creating the project plan. We now have some of the numbers that we need. So for reviewing the documentation, I'm going to put that at 4 hours. The number of test engineers, Mike's going to be the test engineer for today, so I have 1. I will be the lead. The number of ETL legs, it's just 1. There's no intermediary legs. The number of release and cycles, we've estimated at 4. We have 7 low complexity tests, 21 medium complexity tests, and 8 high complexity tests. All right, so we now have the information we need to create a project plan. We're not going to create it from scratch. QuerySurge is building a tool called the QuerySurge Project Plan Estimator tool. It's built in Alchemer, also known as Survey Gizmo. This is in beta format. This is the first time it's being publicly displayed, but it will automatically create our project plan for us based on the information that we've already got, and we could provide it. So I'm going to put my name very quickly in here. I'll use my RTTS email. And Mike, I am going to be the lead.
You got it, Chris. It's your show.
So I click next, the project estimator inputs. It gives you some basic information of what you need to do. We've already discussed most of it, so I won't go into any detail. We are doing the Z City Data Warehouse project, DWH. Oops. Estimate the total times to review project documentation and assets. We said 4. What is the total number of test engineers? I have 1. How many test legs? We said 1. Estimated total number of releases? We said 4. What is the total number of low complexity? I believe we said 7. Mm-hmm. And the medium complexity, 21. And how many highs do we have, Mike?
What was it, 8?
I think you're right. I think it was 8. Does QuerySurge need to be installed and configured? No, for me it's already installed and already configured. Does the test lead require training? No, I am an expert, but Mike is not an expert, so he needs training. You could also set a start date, but we'll just leave that blank for today. And then I'll click next, and these calculations automatically occur. These numbers and calculations are based off of QuerySurge and RTTS's best practice and what we find occurs on client sites and for our customers. So we go through different phases. Our first phase is test strategy, and here are all the tasks associated with doing a test strategy: analyze the documentation, define ETL legs, define environments, define release schedules, define high-level project schedule, define defect workflow, create test strategy document, and any QuerySurge training. And then it breaks it out into how many hours for the lead and how many hours for the engineer.
Well, it seems like you got a lot of work there, Chris.
I do have a lot of work on that step. Phase 2 is test planning. Identify data validation test. This is where we identify. We've sort of already done that to some extent during our previous talk when we talked about the mapping document. Define and assign resources. In this case, it'll be easy because I'm going to assign everything to you, Mike.
Well, so far you've got most of the work, so I'm feeling pretty good.
That's soon to change. Define a detailed schedule, install QuerySurge, and create a test plan. Oh, yeah, you're right. I do have a lot of hours going on there. It's the next phase, though, Mike. This is where it changes. So test design, create low complexity tests, create medium complexity tests, create high complexity tests, verify queries, create query pairs and test suites, and review and oversight. I only have 8 hours in this one, Mike.
It's like I got a lot of work here.
I don't know if my 8's accurate, though. I may have changed that calculation based on who's doing the work underneath me.
Yeah, well,
In this case, you can probably take that number down.
And then execution and analysis, phase 4. Similarly, execute query pairs and test suites, create medium complexity test queries, create high complexity, verify queries, create query pairs and test suites, and review and oversight. And when I click this next button, it'll create a high-level project plan for QuerySurge with some basic terminology, an overview, project assumptions, all the tasks we just talked about, along with all the hours associated with each phase. It then will add up all these in different phases for each of the lead and the test engineer hours. And looks like you got more work than me.
I guess so. It worked out that way.
Resource in days rounded up, so we have 16 days for me, 21 days for the engineer, and in total, it's going to take the engineer is going to be the roadblock here. So that's going to take 21 days or 4.2 weeks, and that is about it. This tool will eventually be available to the public and to our customers from QuerySurge.com. Expect more information to come in the coming months.
yeah. And it's having gone through putting these together, I think, estimating the timelines are one of the hardest things to do, especially at the outset of a project. So hopefully you learned some things today from Chris and his insight here onto how to sort of break down the mappings and the translations and transformations that you'll be seeing. And, this tool definitely will help with that.